All right, this is discussing energy transfer lecture. The bottom line for energy transfer is that you assume that it's a 100% transfer unless otherwise stated. The key phrases for knowing if there is work done on the system, which is by definition change of energy of the system, is if friction's involved, because friction is always a drain and is always worth negative work, or if you push or pull the system. For example, if I kick a ball, I am the environment and I have altered the system. It started to move after I kicked it. Or if I have a spring, let's say I pull the spring, then release it. Well, me pulling the spring is work on the system. Now, if you're not involved in the system and you're just watching, then you do 100% transfer. For example, ball sitting some height above the ground. Well, when it's up here, you have potential energy, gravitational potential energy, and it's just sitting there. The moment it's released, we assume down here, it's nothing but kinetic energy, and we assume 100% transfer. The way we approach these problems is that we look at for initial condition, final condition. So this is like phase 1, phase 2. Okay? In phase 1, we have things happening, and in phase 2, we have different things happening. That is the approach we're going to take. So when we do energy transfers, we're going to do energy initial equals energy final, or energy of condition 1 versus the energies of condition 2. In this case, we know the only thing happening in position 1 is its potential energy, gravitational. There are no springs and it's not moving, so those two are not involved. The moment it strikes the ground, that means it's at its maximum velocity, which means it's on the ground, which means the height is 0, so no potential. There are no springs, so that's out, but it is moving, so we know there's kinetic energy involved. Then we do our substitutions. We know gravitational potential is mass, gravity, height. We know kinetic energy is 1/2 mass velocity squared. Now at this point, the typical questions would be, what's the velocity as the ball strikes the ground? We would just rearrange the equation and solve. But this is fundamentally the bottom lines to approaching every single energy problem. We have phase 1 conditions, we have phase 2 conditions. We look at the initial conditions, we write all the energies involved. We look at the final conditions, we write all the energies involved. We then substitute in with our equations, and then the very last step is to solve for the unknown.